then we can continue. Okay, I hope the screen is visible, right? So we are in this chapter number 2, properties of pure substances. What is a pure substance? Pure substance, the substance that has fixed chemical composition throughout the process. Like example, you can take nitrogen, oxygen, carbon dioxide, etc., which are naturally available. In other case, if you have a mixture of two phases, solid and liquid, but the chemical composition is still the same, like here the example of water is given, it is also called as pure substances. There are some cases like air. If you take liquid air and vapor or gaseous air, in that case we cannot say it is a pure substance. The minimum criteria here it is, the mixture should be homogeneous. Okay, for single elements it is very straightforward. The chemical composition should be constant throughout the process. For mixture it should be like chemical composition should be same and mixture should be homogeneous. So then we have seen the phases. It's a very basic science, we already know. There are 3 phases: solid, liquid and gaseous, right? What is the difference between them? The difference is in the intermolecular bond. In solid, the intermolecular bond is very strong, it has some bond energy. When we heat the solid, then this bond becomes weak, it changes to liquid. If you further increase or supply the heat, increase the temperature, in that case it becomes gaseous. Okay, in gaseous phase intermolecular forces are very negligible. So with this example, we have seen here state 1 was purely liquid, 1 atmospheric pressure, 20 degrees Celsius temperature. I have given some heat, it goes to 100 degrees Celsius. Now for 1 atmosphere pressure, the boiling point of water is 100 degrees Celsius. Okay, so that is why here it is 100 degrees Celsius. Then what happens? Some of the water changes to steam. Okay, here some of the water is changed into gaseous form, that is a vapor form, and it due to its expansion, the lid or the weight placed on that liquid, it changes its position, it raises, right? As further liquid is converted into vapor, it exhausts or it expands and the lid goes in upward direction, right? Here the pressure remains constant throughout the process. Temperature in the phase change, up to phase change, remains constant, 100 and 100. Once it is converted fully into steam, then again the temperature rises, right? So this was the saturation curve. The beginning of this is a phase change process. One point here, it is a liquid. We increase the temperature, it goes to its saturation condition at point 2. Point 2 is called as saturation or liquid saturation point. Then phase change takes place, we supply latent heat of vaporization, we go to point number 4. Point number 4 is a dry saturated condition, liquid saturated, and here point 4 it is dry saturated. In between them you have point number 3, which is called as wet mixture. Okay, after 4, now at 4 the water is fully converted into steam. After 4, if you increase the temperature, if you supply the heat, its temperature will increase and it becomes superheated steam. Okay, so this curve is for 1 atmosphere. Similarly, I will plot for other pressures and I will join all the saturation points, like 2, there will be another 5, 6, like that way I will join all the saturation condition points, and then I'll get this black locus. This black locus is called as saturation curve. The left part here it is liquid saturation curve, right part is vapor saturation curve. What you see at the top, the point here, the maxima here, it is called as critical point. At critical point there is no latent heat is required. Directly at that pressure, liquid is converted into vapor. No latent heat is required. Okay. Again, this left part of the saturation curve, it is called as subcooled region. The right part, it is called as superheated region, and the in between part, middle part, it is called as wet region. Okay. At point number 2, we have saturated liquid. The dryness fraction, that is X, is 0. As we increase the heat, the dryness fraction increases. At point number 4, all the water is converted into steam. Hence, the dryness fraction here it is, or X is 1. Okay. There is another term which is opposite of dryness fraction, which is called as moisture fraction, right? It is opposite to that. At 2, moisture fraction is 100%. At point number 4, the moisture fraction is 0, or moisture percentage is 0. Okay. So this is a property diagram, temperature versus specific volume. Again, the same thing is plotted here. Now, what is the saturation? Saturation defined as condition in which the mixture of vapor and liquid can exist together at a given temperature and pressure. This is a condition where phase change takes place. Phase change can be liquid to vapor or vapor to liquid. Liquid to vapor, it is called as vaporization, and vapor to liquid is called as condensation. Then we have seen this relationship between saturation pressure and temperature. As we increase the temperature, as you can see from the chart also, or from the table also, the saturation pressure increases, and it is vice versa. If the saturation pressure is increasing or the pressure is increasing, the saturation temperature will also increase. Okay, so the pole, whatever we took, it is related to that condition. Okay. So we have seen this saturated and subcooled liquids. Subcooled temperature is the temperature below saturation. Superheated temperature is the temperature above saturation. Okay. Then latent heat, there are two latent heats. Latent heat actually the amount of energy absorbed or released during phase change process. There are two types: latent heat of fusion, latent heat of vaporization. Latent heat of fusion, it is supplied to change from solid to liquid. And तुम्हाला जर liquid to solid करायचं असेल तर that is called as latent heat of freezing. Latent heat of vaporization is a heat supplied to change the phase from liquid to vapor. तुम्हाला vapor to solid liquid करायचं असेल, so that will be latent heat of condensation. ठीक आहे. Then general एक international value दिलेले आहेत. 1 atmosphere pressure ला latent heat of fusion असते 333.7 आणि latent heat of vaporization असते 2 to 56.5. तर ह्या व्हॅल्यूज तुम्ही नोट डाउन करा, because in upcoming chapters these values will be occurring again and again. Now, quality, or in other words, is the dryness fraction. It is the ratio of vapor to the total mixture. Okay, mg divided by mf plus mg. Here g stands for gas, f stands for fluid or liquid. Okay. So this is related to quality. Opposite to that is moisture content. Moisture content is opposite to that. It is a ratio of mass of fluid or the liquid to the total mass. Now, how to calculate a property, right? Last lecture we have seen how to calculate property in the wet region. Okay, in the wet region. Okay, specifically I'm implying in the wet region. How to calculate in subcooled region, how to calculate in superheated region, that I will tell you today. Okay. Now, if you want to plot any property in the wet region, the formula is y. Y can be any property, is equal to yf plus x yfg here. Okay. So for example, I can take specific volume. The wet region मतलब specific volume काढायचा असेल, so first I should know specific volume of saturated liquid plus x, then I should know x, that is dryness fraction, into yfg into this. In this case, this will be vfg. Okay, vfg काय असते? It is the difference between vf and vg minus vf, that is specific volume at dry saturated condition minus specific volume at saturated liquid condition. ठीक है. तर असे स्टीम टेबल आपण गेल्या लेक्चरला बघितले. आय विल शो यू वन्स अगेन. I think we have seen in last lecture. Still, I will try to download it. Okay, I think I have lost it. So once again, I will download it and then we can check. It should be somewhere here, but I'm not able to. Okay, okay. So we can download it from Google also, no problem. Okay, I think now we can open. Yes. So this way, we have steam tables. There is a book you can check by R.S. Kurmi. Okay. So here I will show you the sections. What are the sections in the steam tables? Now, steam table, first we have temperature tables. Okay. So first, if you see, I'll show you. I think I have to rotate the screen. Yes. Okay. View, rotate, view. Right. Okay. I hope it is visible now. So first, if you open the steam table, we have temperature table. So here, first column, we have temperatures in degrees Celsius. Corresponding, we have saturation pressure. Then corresponding, we have specific volume, specific enthalpy, specific entropy, etc., etc. Now, if you go further in the steam table, we have pressure tables. So here comes table number 2, that is the pressure tables. So here in first column, we have pressures in bar. Corresponding, you have saturation temperatures. Corresponding, you have other properties. Okay. Just for example, समजा घ्यायचं झालं, let us say 2 bar. And last lecture I have taken 2 bar. Okay. I will draw a rectangle so that you can be able to see. Okay. Is this clear? Are you able to see the 2 bar pressure is here? करस्पॉन्डिंग सॅच्युरेशन टेम्परेचर इज 120.2 डिग्री सेल्सिअस. म्हणजे काय, जर तुमच्या बॉयलर मध्ये 2 बार प्रेशर असेल तर तुमचं त्यातलं वॉटर कधी बॉईल होणार 120 डिग्री सेल्सिअस टेम्परेचरला. आता 2 बारला जर मला समजा एन्थाल्पी घ्यायची असेल किंवा सॉरी स्पेसिफिक व्हॉल्यूम घ्यायचं असेल पहिल्यांदा, the specific volume of saturated liquid is 0.001061 meter cube per kg. The specific volume of saturated or dry saturated steam is 0.8854 meter cube per kg. जर मला एन्थाल्पी घ्यायची असेल तर एन्थाल्पी ऑफ सॅच्युरेटेड लिक्विड ऍट 2 बार इज 504.7. जर मला एन्थाल्पी ऑफ ड्राय सॅच्युरेटेड स्टीम घ्यायची असेल तर दॅट इज 2706.3 ऍट 2 बार. Similarly, I can go for entropy also. Entropy of saturated liquid at 2 bar is 1.53. Entropy of dry saturated steam at 2 bar is 7.127. Okay. So that like that way you can calculate the properties. आता ह्याच्या पुढे काय आहे, ह्याच्या पुढे आहात सुपरहिटेड चे टेबल्स. ठीक आहे, हे सगळे सॅच्युरेटेड कंडिशनचे टेबल्स आहेत. ह्याच्या येतात सुपरहिटेडचे टेबल, म्हणजे सॅच्युरेटेड कंडिशनच्या देखील तुम्ही पुढे निघून गेलाय. सो दॅट इज अ सुपरहिटेड कंडिशन. जसं की आता परत इथं 2 बार प्रेशर आहे, 120 डिग्री सेल्सिअस आहे, पण तुमच्या बॉयलर मध्ये समजा 2 बार प्रेशर आहे आणि 300 डिग्री सेल्सिअस टेम्परेचर असेल. सो अँड इफ आय आस्क यू व्हॉट इज द कंडिशन ऑफ स्टीम, ओके, तर लगेच तुम्ही टेबल उघडायचे, टेबल मध्ये बघायचं 2 बारला सॅच्युरेशन प्रेशर किती आहे 120, गिवन टेम्परेचर किती आहे 300, 120 पेक्षा जास्त आहे. सो दॅट इज द मिनिंग दॅट द स्टीम इज सुपरहिटेड. ठीक आहे, सॅच्युरेशन टेम्परेचर पेक्षा जास्त टेम्परेचर असेल तर दॅट स्टीम इज सुपरहिटेड. जर टेम्परेचर 120 पेक्षा लहान असेल, सपोज टेम्परेचर 100 डिग्री सेल्सिअस असेल, तर त्या केसमध्ये द कंडिशन इज सबकूल लिक्विड. इट इज स्टील इन लिक्विड फेज. आता पुढे मी काय म्हणलं तुम्हाला, 300 डिग्री सेल्सिअस बॉयलरचं टेम्परेचर आहे. मग काय करायचं, 2 बार बघायचं, इथं 300चं कॉलम आहे. नाउ दिस इज गिव्हिंग यू स्पेसिफिक व्हॉल्यूम. नाउ ऍट 300 डिग्री सेल्सिअस अँड 2 बार द स्पेसिफिक व्हॉल्यूम is 1.316 meter cube per kg. ठीक है, so this way first you can predict the condition of steam, whether it is subcooled, wet or superheated, then you can calculate the properties. ठीक है, so this is for specific volume. Then we have a table for superheated steam. You can calculate specific enthalpy here. This is a table for specific enthalpy, and last we have specific entropy also. Okay, so this way all the data is there in the steam table. आता यातली इंटरेस्टिंग गोष्ट एक दुसरी अशी आहे की आपण 2 बारला काढू शकतो, 1.5 बारला काढू शकतो, पण त्याचं प्रेशर जर इन बिटवीन असेल 1.7 1.8 तर त्याला काय करायचं. सो इन दॅट केस यू हॅव टू गो फॉर द इंटरपोलेशन. ठीक आहे, सॉरी, ओके. ठीक आहे, where is the okay, so this is for the interpolation. ठीक आहे, तर टेम्परेचर 45 आहे, त्याला तुम्ही प्रॉपर्टीज गिवन आहे टेबलमध्ये, 50 ला देखील गिवन आहे, पण तुम्हाला म्हणलं की 47 डिग्री सेल्सिअस टेम्परेचरला प्रॉपर्टीज काढा. तर ते कसं काढणार, तो यू हॅव टू गो विथ द इंटरपोलेशन. इंटरपोलेशनचा फॉर्म्युला काय असतो, तर T2 मायनस T1. ठीक आहे, आता इथं तुम्ही इथं तुम्ही 1 लिहू शकता, इथं तुम्ही 2 लिहू शकता, इथं तुम्ही 3 लिहू शकता. ठीक आहे, काय प्रॉब्लेम नाही. तर काय करायचं, T2 मायनस T1. ठीक आहे, सो आय राईट डाऊन T2 मायनस T1 divided by T3 minus T2. हे झालं LHS. RHS ला तुमचं काय ना, तर सफिक्स आहे असं ठेवायचे, फक्त प्रॉपर्टी चेंज करायची. सफिक्स आहे असं ठेवायचं म्हणजे मी तर घेणार प्रेशर P आणि 2. So P2 minus P1. This will be divided by P3 minus P2. ठीक आहे. So this is a general formula for interpolation. प्रेशरच्या जागी तुम्ही स्पेसिफिक व्हॉल्यूम घेऊ शकता. ठीक आहे. तुम्ही इंटरनल एनर्जी घेऊ शकता, तुम्ही एन्थाल्पी देखील घेऊ शकता, काही प्रॉब्लेम नाही. Now here by interpolation they have calculated saturation pressure at 10.698. Other properties also you can calculate. So last lecture only one student had calculated. I am giving you another opportunity. Others also participate and calculate the other property, that is specific internal energy and specific enthalpy. So use the same interpolation technique and calculate U and H. Okay, so you can type that into the chat box. Okay, so Akanksha has calculated, Aditi again calculated. Okay, so others, what is the problem? You don't have calculators or what? Or you don't want to participate? Calculate, everyone. Check if their answers are correct. Use the interpolation. Okay, I'm feeling like I'm teaching to some arts or commerce students because you are not in participating in the calculations, right? Others, calculate and verify with the answers given in the chat box. Yes, others I hope are calculating. Sudhir, okay, sir, please explain how to calculate. Sudhir, pay attention. So what the problem here it is that steam table मध्ये तुम्हाला एक स्टँडर्ड व्हॅल्यू दिलेले असतात म्हणजे 5च्या रेंज मध्ये 10च्या रेंज मध्ये जसं की 45 ला तुम्हाला व्हॅल्यू दिलेली असतात 50 वाली दिलेली असते पण नेहमी काय 45-50 मध्येच टेम्परेचर असेल असं काय आपण सांगू शकत नाही तर त्यामध्ये समजा इन बिटवीन टेम्परेचर असेल 47 असेल किंवा 47.5 47.8 काही का असेल ना त्यावेळेस तुम्हाला पी सॅट व्ही यू एच एस या प्रॉपर्टी काढायची असते तर वी हॅव अ इंटरपोलेशन टेक्निक. So this is a table given, a reference table. So I have plotted this levels as 1, 2, 3 level. आता तुम्ही काय करणार आहे? There is a formula. What is formula? T2 minus T1 divided by T3 minus T2. That means T2 here it is 47, 47 minus 45 divided by 50 minus 47. This will be LHS, RHS will be P2 minus P1. Suffix हायच ठेवायचे फक्त प्रॉपर्टी चेंज होतील P2 minus P1 divided by P3 minus P2. ठीक आहे? So just you have to put the values. तर टेम्परेचरच्या व्हॅल्यूज तर सगळ्या नोन आहेत. प्रेशरच्या फक्त तुम्हाला P1 माहिती आहे आणि P3 माहिती आहे. तुम्हाला P2 माहित नाही. So you have to calculate the P2 value. Simple math, it is there. Last lecture I have told you to download that calculator, that is Calc ES. Okay, I have put in the chat box. You can check that also. Using the Calc, first download that app Calc ES. It is a scientific calculator. Okay, and in that you can do same operation that you used to do in or Calc. Okay. In that you can create equations like this, and if you go for shift solve, in that case the Calc will directly give you the answer, that is P2. Okay. Okay, one more person has calculated. Who is this? Yamgar Shubham. Okay, okay. So the answer here it is specific volume will be 13.94 meter cube per kg. U that will be 2437.74 kilojoule per kg, correct? And H2 will be 2585.9 kilojoule per kg, correct? I hope Sudhir you have understood now. तुम्ही वाटल्यास एक्सेल देखील वापरू शकता. एक्सेल मध्ये देखील तुम्ही इंटरपोलेशन करून व्हॅल्यूज करू शकता, काही प्रॉब्लेम नाही. Last lecture that also I have taught you how to use Microsoft Excel to draw the plots. Okay. Okay. Next part. So then we have to one example, that is we have to calculate the enthalpy of 1.5 kg of water contained in a volume of 1.2 meter cube at 200 kilopascal. म्हणजे तिथे एक क्लोज बॉक्स होता. ठीक आहे. व्हेरी सॉरी. असं काही क्लोज वेसल आहे, त्यामध्ये 1.5 kg वॉटर आहे आणि त्याचा व्हॉल्यूम आहे 1.2 मीटर क्यूब आणि इट इज ॲट 200 kilopascal. ठीक आहे. So 200 kilopascal is nothing but 2 bar. 100 kilopascal is 1 bar. 200 kilopascal, it is equivalent to 2 bar. Okay. So first step here they have calculated specific volume which comes out to be 0.8. आता 0.8 आल्यानंतर तुम्हाला बघायचं की कंडिशन काय आहे, whether it is subcooled, saturated or superheated. मग तुम्ही काय जाणार, स्टीम टेबल मध्ये जाणार. ठीक आहे. युल सर्च फॉर 200 kilopascal. आता मी पण जातो स्टीम टेबल मध्ये. So here it is a steam table. आता मी काय करणार स्टीम टेबल फॉर प्रेशर आणि त्यात 200 किलो पास्कल म्हणजे 2 बार. ठीक आहे. आता इथं आहे बघा 2 बार. आता इथं VF आणि VG ची व्हॅल्यू बघा किती आहे. VF हिअर इट इज at 2 bar it is 0.001 and VG is 0.885. आपलं आलेलं स्पेसिफिक व्हॉल्यूम किती आहे. Our specific volume is 0.8. So 0.8 lies between these two values. So we can say the condition of steam is wet. Okay. Now here then we have to calculate the quality of steam or the dryness fraction, that is X. So we have to use the formula V is equal to VF plus X into VG minus VF. From table VG is known, VF is known, right? And we have calculated that is 0.8. That is also known. Only unknown is X. X we have calculated here it as a 0.903, or we can say 90% is the dryness fraction or the quality of the steam. So next is to calculate the enthalpy. Again, same formula for the wet steam is H is equal to HF plus XG. So from steam table, again I will go to steam table. What is HF value? HF value at 2 bar it is 504.7. Hg value is 2706.3. I will put that values in the equation. I will get the enthalpy as 2492.7. 2492.7. Okay. I hope you know. So always remember, first step is to know condition of steam. Condition of steam. Okay. I don't have tab today, so that is why I have to type. Draw this very carefully. Condition of steam. So you have to know whether it is a subcooled liquid or it is a wet steam or it is a superheated steam. कधी कधी एक्झाम्पल मध्ये डायरेक्टली दिलेलं असतं की सॅच्युरेटेड लिक्विड आहे किंवा ड्राय सॅच्युरेटेड स्टीम आहे असं डायरेक्टली दिलेलं असतं. त्यामध्ये मग पहिली स्टेप तुमची सोपी होऊन जाते. दुसरी स्टेप असते कॅल्क्युलेशन ऑफ ड्रायनेस फ्रॅक्शन. ठीक आहे. एक्स व्हॅल्यू तुम्हाला काढावं लागते. तिसरी स्टेप आहे तुमच्या काय जे काही प्रॉपर्टीज आहे त्याचं कॅल्क्युलेशन. प्रॉपर्टी म्हणजे एक्झाम्पल मध्ये सांगितलं असते एंथॅल्पी काढा, एंट्रॉपी काढा, व्हॉटेवर. ठीक आहे. So today I will cover the rest part, that is calculation in the subcooled region and calculation in the superheated region. Okay. Okay. One more example we'll take. It is related to superheated steam. So the question here it is: consider a closed rigid container of water as shown. Pressure is 700 kilopascal, or we can say 7 bar. Mass of saturated liquid is 1.78 kg, and the mass of saturated vapor is 0.22 kg. Total mass किती असणार आहे? 1.78 plus 0.22, that is 2 kg. Heat is added. आता इथं अजून एक आहे की 2 kg total mass आहे plus हे this is a mixture of liquid and vapor, that means it is a wet steam. Next is heat is added to the water until the pressure increases to 8 megapascal. Okay. Or we can say 80 bar. See, initially it was 7 bar. We have to increase the pressure to the 80 bar. Okay. So 1 megapascal is equivalent to 10 bar. Okay. Find the final temperature, enthalpy, internal energy of the water. Again, directly in this case, they are given it is a wet steam. Dryness fraction you can calculate, that will be mass of vapor, that is 0.22 divided by total weight, that is 2 kg. So that will give you dryness fraction. Once you know the dryness fraction, then you can calculate the other properties. Okay. Right. So here now theoretically first is V2 is will be equal to V1, because this is a closed system. Specific volume will be constant. Okay. There is no room to expand the steam, right? The quality before the pressure at state 1, that is 7 bar. X will be equal to 0.22 divided by 2 kg. That comes out to be 0.11, or we can say 11% is the quality of the steam. Now, initially, the specific volume we can calculate from the steam table. Again, the formula is same. As we know, it is a wet steam. The formula will be V equal to VF1 plus dryness fraction into VFG. Okay. आता परत त्यांनी suffix 1 दिले, that is for state 1. From this they are calculated V1. आता V1 will be equal to V2. ठीक आहे. और V2 केस मध्ये परत आपल्याला ड्रायनेस फ्रॅक्शन काढायची गरज लागू शकते. ठीक आहे. Now second state is 8 megapascal or 80 bar. V2 will be equal to V1, that is 0.031 meter cube per kg. Now from table, again at 80 bar, we have to know VF2 and VG2. So at 80 bar, so I'll go to the steam table. We'll go for the 80 bar value. Okay. So as you can see here, this is the 80 bar. Okay. So as you can see here, it is 80 bar. At 80 bar, VF is 0.001384. VF is 0.023. आपलं किती आलेलं आहे specific volume, that is 0.031. Now you see the VF आणि VG ची व्हॅल्यू बघा आणि V2 ची व्हॅल्यू बघा. So V2 value is greater than VG. ठीक आहे. So in second case, the quality of steam is superheated. ठीक आहे. ही जी प्रॉपर्टी आहे ती जर VG पेक्षा जास्तच असेल, that is the dry saturated condition पेक्षा जास्तच असेल, so that lies in the right side of the saturation curve, which is a superheated region. So we can say it is a superheated steam. Now the temperature, now we have to go for the superheated tables. Okay. Right. So we have to go to the superheated tables. Now I'll go for the 80 bar superheated table. So 80 bar superheated table. 80 bar. Okay, here it is. Now if you want to know the temperature, we have to go to the temperature superheated tables. Not the temperature, sorry, enthalpy and etc. If you want to know the temperature, you can get from the specific volume table. We have to know the pressure is 80 bar. So where is 80 bar? 80 bar. Yes, here it is 80 bar. So I will put yes, here it is 80 bar. So see here our specific volume, in this case it is 0.031. So it lies between, so here you can see here it is 0.029 and here the specific volume is 0.034. Okay, so our value is 0.031. So in this case your temperature will lie between 350 and 400. Again in this case you can go for the interpolation. Interpolation ह्या केस मध्ये कसं असणार आहे? So it will be V2 minus V1 divided by V3 minus V2. That will be LHS, easily can be calculated from table, equal to here T2 minus T1 and divided by T3 minus T2. Okay, from that interpolation you can calculate the temperature value. If you want to know the specific enthalpy, again you have to go to specific enthalpy superheated table. You have to go for 80 bar pressure. Sorry, why it is not coming. Yes, okay. Here, yes, okay. Again, you have here 80 bar pressure and the temperature is known. We have just calculated temperature is 361. Again, you can see here in the table there is no column for 361 degrees Celsius temperature. Again, you have to do the interpolation. So by interpolation, you can calculate the specific enthalpy. So that will lie between 2989 and 3141. आता बघा येते. Sorry. So the specific enthalpy 3024. So it lies between, sorry, 3024. So 3024 is lies between these two values. Okay, 29899 and 314 च्या मध्ये कुठतरी 3024 lies होते. So it is calculated by interpolation. Now, and the last is specific internal energy. So that also can be calculated from the tables, right? Okay. Now, how to calculate properties in subcooled region? Okay, त्यासाठी मी एखादा graph for reference पकडतो. Right, so I'll take this one. So how to calculate properties that lies okay, so they're saying, so sorry sir, but I'm not able to calculate the value of H. So by interpolation, we can calculate the value of H. So don't worry, in next lecture, this example, whatever we have just took, I'll explain the last part, that is the interpolation part in next lecture. But by interpolation, of course, you can calculate the any property which is not available in the steam table. Okay, so wait. Right. So my question here it is, you can now calculate the properties which are inside the weight region. ह्यातल्या property तुम्ही काढू शकता. तो फॉर्म्युला ठरलेला आहे. काय आहे? समजा मला H काढायचा असेल, so H will be equal to HF plus X, that is a dryness fraction, into HFG. ठीक आहे, HFG is a latent heat. किंवा तुम्हाला माहित नसेल HFG काय आहे, तर HFG मी I will write down here. HFG is difference between Hg, that is the enthalpy of dry saturated, minus enthalpy of liquid saturated, that is HF. Okay, it is very simple. For the weight region, the formula we have seen now. Now what about subcooled? Okay, what about subcooled? Okay, so if you want to calculate, let us say, enthalpy of subcooled, suppose इथं कुठे तुम्हाला enthalpy काढायची या पॉइंटला. Let us say this point as already 1 2 3 4 is taken. Let us say this point as 5. तुम्हाला point number 5 मध्ये enthalpy काढायचं आहे, which lies in the subcooled region. This will be equal to, I will again extend it up to here, and here is our HF. So I will extend. Right. So here it is lies our HF, that is the enthalpy of liquid saturated steam. आता ह्या केस मध्ये तुम्ही बघू शकता HF. Okay, just wait, I got a call. Okay. Now in the subcooled region, how to calculate enthalpy? This will be equal to HF. That is the enthalpy of subcooled, the liquid saturated condition, minus Cp delta T, the specific heat of that liquid into delta T. So this part, this difference, what you see here, this difference is Cp delta T. Okay, specific heat into change in temperature. What is change in temperature here? So here delta T is nothing but the saturation temperature, that is corresponding to HF, saturated condition. So pardon me, minus the temperature we are at. Let us say point number 5. Here also point number 5. So in order to calculate the any property in the subcooled region, take the property at saturated liquid condition minus C delta T. In that case, you have to know the C value. C value, that is the specific heat value for water. It is constant and it is standard. That is 4.187 kilojoule per kg. Okay. Now, what about superheated region? Okay. What about superheated region? In this case, if you want to calculate the enthalpy, let us say at point number this one, point number 6. Again, you have to know the enthalpy of saturated, dry saturated condition, that is Hg, plus again you can do the same Cp delta T. Here delta T will be T6 minus T saturation. Okay. So this way you can calculate the enthalpy. Formulas for entropy are slightly different. If you want to calculate the entropy, let us say at point number 5. So specific entropy at point number 5 will be equal to SF, specific entropy at liquid saturated condition, minus C log T2 minus T1. Here it will be T5 T sat divided by T5. In the case of superheated region, the entropy of the superheated region at point number 6, this will be equal to entropy, specific entropy at dry saturated condition, plus again Cp, it is a specific heat at constant pressure, into log, natural log T2 by T1. Here T2 will be T6 divided by T sat divided by saturation temperature. I hope it is visible because I'm going in the extreme right corner. Okay, so this way you can calculate the properties. Okay, write it down. Enthalpy can be calculated HF minus Cp delta T, C delta T. Specific heat for liquid, it is a constant value. There is only one value. But if you go to the gaseous phase in the superheated region, there will be two specific heats, Cp and Cv. So here enthalpy will be equal to enthalpy at dry saturated condition plus Cp delta T. Entropy formulas are different. Entropy of subcooled liquid is SF minus C into log T sat divided by T5, or that point where we are interested. For superheated, entropy will be entropy of dry saturated plus Cp log T6 by T sat. 6 point is in the superheated region. So in next lecture, we'll try to solve more numericals. I think students are still understanding how to calculate. So we'll take a practice session, we'll solve the numericals, and I think at that point your understanding of the calculation of properties will be easy, because this is very important for the next chapter, that is vapor power cycle, in which we are going to calculate the performance of whole thermal power plant. In that also we are going to calculate these properties again. So if you are well at calculating the properties at this point, then and then only you can calculate performance in the next chapter. Okay, so don't worry, in next lecture I will take numericals related to steam tables. Right. I think this is sufficient for today. I hope you have written down these formulas. Right. So type your attendance in the chat box and then we can stop. So type your attendance in the chat box and then we can stop. So once another session I will also take related to using of Microsoft Excel, using of Microsoft PowerPoint. Okay, one session will be for basics of Microsoft Excel, in which I will teach you how to use the formulas, how to generate the graphs, etc., etc. Okay. So I think this is sufficient for today. With this, we'll stop. Thank you for attending. We'll see you in next lecture.